Okay, we return to the restaurant odors problem. Remember that through the ANOVA procedure, we rejected the null hypothesis that the average time spent by the customers in the restaurant, given the three treatments, lavender, lemon, and no odor, were the same. That we rejected and found that there were differences, that one of these treatments is, at least one of them, is significantly different than the other. So the Fisher's method, outlined in the book, talks about three different approaches, which in some sense are all equivalent. One is just running a hypothesis test on taking two of these populations at a time. Another version of that is building confidence intervals. If you remember, a lot of times that we could look at a confidence interval and determine if an equivalent hypothesis test would end in a rejection or not significant. So the approach that I'm going to take here is with the confidence intervals. And the formula given for that is x sub I, whatever your first sample is, and your second sample, x sub j, plus or minus t alpha over 2 times the square root of MSE. Remember, MSE is a good estimate of the population variances, and we've assumed that all populations have the same variance. That's a condition for running ANOVA to begin with. MSE is a good estimate of that overall population variance that the three populations are equal to. This is a confidence interval really that we had in Chapter 10. Although we would have said under the radical sign here, we would have had S sub 1 squared over n sub 1 and S sub 2 squared over n sub 2. But again, we're assuming the same variance, and MSE is an estimate, a good estimate of both of those variances. So really this is the same confidence interval we've had before. Now, T alpha over 2, our alpha value is 0.05, so we'll divide that by 2, and T sub 0.025. The degrees of freedom is equal to the degrees of freedom of MSE, and the degrees of freedom for MSE is NT, the total in all the samples, subtract K. So for us, that is 54, subtract 3, 51. Now if I go to the T table and look in column 0.025 for the upper tail area, and row 51, I get the critical value of 2.008. And that will be true regardless of what pair of sample averages we're looking at. Okay, let's start out and look at the first two sample averages. The one that was taken for the people that were exposed to the lavender odor, and the second one, people that were exposed to the lemon odor. And the averages for lavender was 106.25, and the lemon was 91.125, plus or minus 2.008 times the square root. MSE we calculated earlier as 232.42, and the sample sizes then 20 for the lavender and 16 for the lemon. Now as we calculate through that, we get 15.125 plus or minus the margin of error 10.27. And we really don't need to build the final confidence interval, we can recognize that when you add and subtract 10.27 to 15.125, you're going to get a lower end and upper end being positive. So essentially, under a 5% level of significance, we have 95% confidence that the difference in the population averages is positive, meaning that the average amount of time spent by the customers with the lavender being present is greater. So there is a significant difference between mu1 and mu2. Now let's go on and compare 1 to 3. That's the lavender and the no odor. So I'm going to take the sample data that I have, estimating the average amount of time, and see what the difference in that average amount of time is. And then I'm going to add on my margin of error. Now it's too bad that the sample sizes are different, because if they were the same, it would be exactly the same margin of error, 10.27. But because the sample sizes are different, that's going to change this a little bit. So 1 over 20, but now 1 over 18. And when I do that calculation, I will get 18.36, and I'm going to add and subtract 9.95. Well, I still can conclude two positives, indicating that the average in the differences between mu1 and mu2 is significant. So we have a significant difference here. In other words, the lavender, the amount of time that the average amount of time that customers spend in the restaurant when there's a lavender odor is significantly different, significantly larger, I should say, than the average amount of time the customers spend in the restaurant when there is no odor. And there's one more combination to check, and that's between 2 and 3. That's between when there's a lemon odor and no odor. And I will take my sample from population 2, 91.125, and subtract the 87 from population 3, the average amount of time, the estimated average amount of time customers would spend when there was no odor. See if that difference is, if the difference in the population averages there is significant. I still have a different margin of error, so it'd be 1 over 16 plus 1 over 18 this time. And my average is 3.24. They're a little bit closer. That's my estimate for the difference in the population averages. My margin of error is 10.52. Now if I subtract that from 3.24, I'm going to get negative on the lower end and positive on the upper end. That means under an alpha 0.05 level of significance with 95% confidence, in other words, it could really be one or the other. The difference could be positive or it could be also negative. So under that level of significance, I'm not willing to risk saying that there is a significant difference here in the population averages. So I will say no significant difference. Now that doesn't mean they're the same. It just means, again, like it is always meant, when you can't reject the null hypothesis, it doesn't mean the null is true. It just means that there's not enough difference in the sample averages to make a claim that there's a difference in the population averages. So I'll say no significant difference here. One way of thinking about that is 0 in the interval or not. If 0 is in the interval, that means you've got a plus or minus or a minus plus. If 0 isn't, you have 2 pluses or 2 minuses. Now, for sake of argument, if we had a confidence interval with 2 negatives, that would just simply mean that the second one was larger than the first one. But the fact that under an alpha 0.05 or 95% confidence that there were 2 negatives just would mean that 95% sure the second one was larger. So we can now draw a more specific conclusion here. We can say that it appears that the average time spent in the restaurant by customers when there was a lavender odor was significantly more than when there was lemon or no odor. In other words, the lavender odor has a significant effect to increase the amount of time customers spend in the restaurant. And we have statistical proof that it's significantly better than lemon or no odor at all. Now, because we got a no significance between the lemon and no odor, we are not willing to claim that the lemon odor significantly increased the time spent compared to when there was no odor. Now, even though my lemon sample average is greater than my sample average for the no odor, that's not enough proof statistically under alpha equal to 0.05 that there's a significant difference between mu2 and mu3, the actual population averages. So there's just not enough evidence here to say there's a difference. It doesn't seem that the effect of lemon was strong enough in the sample evidence anyway. I'm not going to say that the lemon isn't significantly different. I just don't have enough evidence to say that it is. But I do have evidence to say that the lavender odor does have an effect, an increase on the amount of time that customers spend in the restaurant.